Hello, I wanted to work through this example from the textbook just so that you know where it comes from. You can grab it from the exercise set in the book if you go to page 75 in the text and click on this icon. You can see the pop-up dialog says exercises 13 and 15. So to solve this problem, we're going to first construct a relative frequency distribution. And so to do that, we're going to take and add all of these numbers up, the frequency 438 plus 492 plus 968 plus 341 plus 22. So we got 2,261 people here. And I'm just going to do that one more time just to make sure I didn't make a mistake. 492 plus 968 plus 341 plus 22, 2,261. So now I'm going to just write that down. Total 2,261 people in the survey. So we're going to take 438 people of the 2,261 who said never to 3 decimal places. That'll be 0.194. And then I'm going to go ahead and put that in. Let's see, where did it go? 0.194 to the nearest hundredth. 0.194. Then to get rarely, we'll go, oh, wrong thing. We'll go 492 divided by 2,261 to the nearest 3 decimal places, 218. 0.218. And sometimes we'll take 968 divided by 2,261 to the nearest 3rd decimal place. That'll be 0.428. 428. Yes. Then we'll take most of the time. 341 divided by 2,261 to the nearest 3 decimal places, 0.151. And then, let's see here. So we'll take 22 divided by 2,261 to the nearest decimal, 3rd decimal place. That would be that 9. We'll round up to a 1, 0.010. 0.010. Then we'll submit that. Okay, in the system like that, excellent. Now, to figure out what percentage responded always, we're going to take that number, multiply by 100, 0.010 times 100. Oh, I did that wrong. 0.010 times 100. That is not right. I'm not sure why. 0.010. Oh, times 100. Roger, you knothead. 1%. There we go. Oof. Never or rarely. Now notice this is what percentage of respondents answered never or rarely. So we need to look at the sum of those two, 0.194 plus 0.218 times, let me try again, 0.194. Those are the people that responded never, narrowly. These are the people that responded rarely. Multiply by 100 to get 41.2%, and we want to go to 1 decimal place. There's that. Continue. Construct a frequency bar graph. So we can actually get this just by looking at the table and eliminating answer choices. So it can't be bar graph C, because if you notice, sometimes is the largest proportion, and then so we can eliminate C. And then also look at the frequency on this vertical axis. It's not the relative frequency, it's the actual frequency. So we don't want to look at this table, we want to jump back over to this table. And then it's clearly not this one, because always is 22 people, so it can't be that. And it can't be that because sometimes should be closer to 1,000 people, so we know it has to be that one. All right, and then we got a couple more parts. So now we have a relative frequency bar graph, so we want to go look up at the relative frequency chart. And then let's see if we can eliminate any of these choices. We know this can't be B because 22 people said always, but that's not 22%, so it's definitely not B. And then it's definitely not A because the most frequent category was sometimes, which was about 42%. And if you look at this, sometimes is just barely over 20%, so it has to be this one. Oh, except nope, it can't be that one because the always is too large. Yeah, it's got to be this one. There we go. Continue. Construct a pie chart. So we need sometimes to be more about slightly less than half. So we know it's not B, and we know it's not C. Always is purple. That needs to be a very small portion. So it can't be B, and it can't be C or D, so it has to be A. Suppose a person claims 1% of all people in the nation always eat out. Is this a descriptive or inferential statement? This is a descriptive statement because it is a description, if you will, of some segment of this data set or this population. This tells us, this describes something that's true about this group of people. For it to be inferential, we would have to be using the data to say something that the data don't say directly. So this is definitely a descriptive statement. What? Oh, oops, I read that wrong. Suppose a person claims at one point, oh, silly me. Let me explain this more. I read the question wrong. And so good problem solvers always read the question more than once. And so here's the reason that this is actually inferential. Suppose a person claims that 1.0% of all people in the nation always eat out. This is not a sample of all people in the nation. This is a sample of 2,261 people. So this is definitely an inferential statement. And so you can go through and do that again as a similar question if you want. I'm not going to, just because in this video it would be super long. But anyways, I hope that this was helpful.